Scanning electron microscopy. In short form, this is known as SEM. As the name suggests, SEM is one type of electron microscopy techniques and addresses the resolution problem associated with the light or optical microscopy techniques. Unlike light microscopy, in electron microscopy, a beam of electrons is used as a source to probe the surface morphology of specimens or samples. Principle: when a beam of electrons, what is referred to as primary electrons, interacts with matter on a surface, backscattered electrons, secondary electrons, X-rays and Auger electrons are produced due to the interaction of primary electrons and the surface molecules. In the SEM analysis, microscopic image is constructed based on the contrast of either backscattered electrons or secondary electrons. Unlike the light microscope and scanning probe microscope, in SEM there can be more than one detector depending upon the need and necessity of our analysis. For example, one for the detection of backscattered electrons and another one for detecting the secondary electrons. In addition, in modern scanning electron microscope, we can find another detector which is generally a X-ray detector to get insight into the composition of material under investigation. Nowadays, most of the scanning electron microscopes are having either backscattered electron detector or secondary electron detector along with the energy dispersive X-ray detector. A typical SEM will have electron source or electron gun, electromagnetic lens, backscattered electron detector or secondary electron detector, X-ray detector. Resolution of a scanning electron microscope depends upon primary electron beam diameter. With a conventional heated filament electron gun, we can obtain an image resolution up to 10 nanometer, whereas field emission scanning electron microscope gives an image resolution up to 1 nanometer. According to the de Broglie relation, wavelength of electron decreases with increasing the acceleration potential. Most of the scanning electron microscope will have an operating electron source at 30 kilovolts. Overall, a SEM resolution is far better than any optical microscope, but lower than a transmission electron microscope. One of the major advantages of SEM is that we can image very thick samples, which is not possible with any other microscopy techniques, especially with TEM.